As new architectural patterns like separation of compute and storage evolve, object storage is increasingly the first choice for applications to store primary, non-archival data. This is in addition to the old use cases of archival and large blob storage. MinIO is an open source AWS S3 compatible object storage platform, allowing developers to use one of the most common object-based storage options without vendor lock-in and with increased flexibility. As many production workloads move towards MinIO, it's critical for businesses to audit and track each and every access to their MinIO cluster. MinIO exposes both audit logs and its internal server logs via a simple REST API endpoint, and then you can point this to your logging infrastructure. This is perfectly suited to writing to external services optimized for logging, such as Parseable. In this video, I'm going to walk you through setting up a MinIO and Parseable cluster using Kubernetes and Helm charts, configuring the MinIO cluster to point to Parseable and then write data to Streamlogs there. I use an example application that generates random text files to write them to MinIO, whilst also writing logs to Parseable. And then writing to Parseable means you benefit from its features such as alerting, logs, dashboards, charts, etc., etc. Okay, let's get started. The first thing we need is the Parseable service. On Kubernetes, the preferred way to do this is using the Helm chart, which I've got here. And you can find more details about that in the link on screen. And then to access that service, we need to port forward to the service here from an external port to the service port. There we go. And even though there's not going to be very much to look at right now, here is the Parseable service. The default username and password, if you don't change anything, is admin. And where might you change anything? Included in the repository for this video is this Parseable env secret, which sets a bunch of default details that get used when you use that Helm chart. So you could change them here. Next, I'm going to create the streams that we will use. Firstly, the audit log, which will be the one that gets pretty much everything written to it. Schema type can remain as dynamic. Everything here can actually remain as default. And then a logging one, which unless your particular setup has any problems, it's highly likely nothing will actually get written to it. But there's the two streams. So the next step is to start the MinIO service. I'm going to take a look at this file. This is the Kubernetes YAML file that defines the MinIO service. Firstly, there is a namespace. If you change this namespace, you also need to change it here in the pod definition. There's the image. The most important parts are these environment variables. Firstly, you need to enable each webhook here. Then the URL, you can use the internal Kubernetes service URL and then just add on the stream you want to send to. And then finally, you'll need the Parseable auth token. If the username and password are still admin and admin, this will work. Otherwise, you need to base 64 encode it and then put that value in there. And taking a look at the demo application, it firstly needs the access key and the secret key, which you get from this access keys section of MinIO. And when you create one, you see the values. You have to copy those then. Pretty normal for access keys. It uses the Faker library to generate random text files that are then uploaded to MinIO. Let's say they are text transcripts, something like that. Each time you run it, it loops somewhere between 50 and 1,000 times, generates between 5,000 and 20,000 lines, creates a random file name, saves them locally in this files folder, and writes the content to the file, sets the destination bucket. If the bucket does not exist, it is created, adds some random metadata, then uploads the file from the local file system to the MinIO file system, then deletes it locally. And then so we can get some get operations as well, then re-downloads the file into the temp folder locally. And if we now jump over to here, we can run the application a few times. As it's somewhat random, it can take a little bit of time or a long time, who knows, but you can see the operations happening here. If I jump over to, you can see the files getting created and removed. If I look inside the temp folder, you'll also see the files coming and going and the sorts of ideas of sizes. Generally, no bigger than 10 megabytes, but everything also down to a couple of K. So I'll run this a couple of times and then we will look at the result. And the result here you can see in the bucket. It's reasonably large. See all the files here. You could do a bunch of different operations here, but we're more interested in seeing what's happening on the Parseable side. So 9.7 thousand events. And you can see the compression here. That's actually helping keep that relatively small. So this is sort of helpful. We can see a lot of the events in the table format here, but Parseable also has dashboards. Sometimes it's worth just expanding the time range here. And I have a couple here I'm going to walk through to show you the sorts of data you could visualize. It depends a little bit on the source data, of course. So in this particular case, this is the top large files. So let's have a quick look. This is all in SQL. So here we're selecting the API object, which is the file and its size from the table where it's bigger than 20 kilobytes. Some of these are much bigger than that. Order it by the size and then restrict it to the biggest 10. And if we hover over here, we can see these are all a lot larger, all basically nearly 10 megabytes. And we could change the visualization type here, but I think this one makes the most sense. You can change the size, change the color to make it something more urgent looking. There we go. You can see the data preview here. We can also refresh the data if we want to. Here we have the operation count. For this particular demo application, it's mostly going to be put, get, the bucket head, and the object head. We can have a quick look here. So again, we are creating a count of the API name used, grouped by it, and limiting it by 100. And again, if we have a look into the chart, we could change it to different types. And in this case, we have the x-axis and the y-axis. You can add more y-axes here. There's also the table. And in this case, it's pretty similar to the last one. We get a count of the API bucket and the API name. So the bucket it went to, which is going to be the same one each time, and the method that was used, grouped by those two. And in this case, we display it as a table. So the vast majority is put get. I mean, you saw this on the graphic already. And then finally, data transferred. This is probably quite useful when this is a real cloud store, because you then have a vague idea of how much it's going to cost you. But on this particular demo application, it's not showing anything massively useful, but let's have a quick look again. It's the sum of the transfer from the name grouped by the name. So we can see that the one that costs the most, unsurprisingly, is the put object here. Pretty large. All of these can also be downloaded as a PNG, CSV, or just the raw JSON, which you saw in that preview. One other thing you can do with dashboards and their tiles is share them. Share the JSON definition of them that you can then import back into another instance of Parseable. So I will save that's the entire dashboard and also each individual tile here. This now means that you can import a dashboard from here or import a tile from here, putting in the JSON file. In this video, I looked at connecting MinIO's audit and error log to Parseable. And with Parseable, you can then analyze, store, and do many other things with that log data. If you're interested in finding out more, then head on over to parseable.com or the links you can see on screen.